Welcome to GCSE Maths Help. Today we're going to be looking at probability exam paper questions. This video is a follow-on from my Probabilities Key Points video, which I will link in the bio below. If you haven't watched that video, you might find it useful before looking at exam questions. For everyone else, let's get started. Before we start looking at exam questions, I'd like to share with you the best piece of advice that I was given when I was doing my Maths GCSE, because I feel like it's really relevant for probability questions. I was told that all the information given to you in the question on a maths paper must be needed at some point during the question, especially the wordy ones like probability questions. If the question says, Adam goes to the shops and buys 2 apples and 4 bananas and drops 2 apples on the way home, then all of these points must be relevant to what you need to work out. There's never going to be any extra details like Adam went to the shop on a windy day and he wasn't sure what kind of coat to put on, because these details aren't relevant to the maths that you're doing. So if you ever don't know where to start with a question, think about the information you've been given to see what you know for sure. And keeping that in mind, if you get to the end of a question and there's some information that you haven't used, then go back and have a little rethink about what you've worked out, because you will have needed that information at some point during your answer. So the first question we're going to look at says a bag contains 20 red discs. 10 are red, 7 are blue and 3 are green. Marnie takes a disc at random before putting it back in the bag. Nick then takes a disc at random before putting it back in the bag. Ollie then takes a disc at random. Work out the probability that they've all taken a red disc. So the key here in this question is that when they've taken a disc, they've put it back into the bag, so the probability isn't changing each time. So the probability that Marnie takes a red disc is 10 red discs out of the 20 in the bag. The probability that Nick takes a red disc is 10 red discs out of the 20 in the bag, and the probability that Ollie takes a red disc is 10 red discs out of 20 in the bag, and we want to work out the probability that all of these happen. So event A and event B and event C happens, so we need to times them all together. So we can simplify the expression first. We can divide top and bottom by 10 to give us a half times a half times a half, which is equal to an eighth. So there's a 1 in 8 chance that all 3 of them will pick out a red disc. So part B of the question says all 20 discs are in the bag. Reggie takes 3 discs at random, one after the other. After he takes a disc, he doesn't put it back in the bag. Reggie's first disc is blue. Work out the probability that all 3 discs are different colours. So the key here is that the discs are not returned to the bag, so the probability when Reggie is taking discs is going to change each time. There was also a big space at the bottom of the question, which is a clue that we're going to be drawing a tree diagram. So I'm going to write at the top the information from the first part. So we had 10 red discs, we had 7 blue discs and we had 3 green ones, totalling 20 discs in the bag. So if the first disc was blue, the second disc could either be red, it could be blue, or it could be green. So the probability that the second disc is red is going to be 10 red discs left in the bag because the first one was blue, but there's now only 19 discs in the bag. The probability that the second disc is going to be blue is going to be 6 blue discs that are left in the bag out of the 19 discs that are left. The probability that the second one is going to be green is going to be 3, because we've still got 3 green discs in there out of the 19 that are left in the bag. So then Reggie takes a third disc, so it doesn't matter what colour our second or our first one is, the third ones could be red, could be blue, or could be green. Could be red, could be blue, or could be green. Could be red, could be blue, or could be green. So starting at the top, after having lost a blue and a red disc already, the probability that the third one is red is going to be 9 out of 18 that are now left in the bag. The probability that the next one is a blue one is going to be 6 out of 18, because we've already lost a blue one. The probability that it's going to be a green one is going to be 3 out of 18 because we've not lost a green one yet. So on the next branch, after losing 2 blue discs already, the probability that the next one is going to be red is going to be 10 over 18. The probability that the third one is going to be blue is going to be 5 over 18 because we've already lost 2 blue discs already. The probability that the last one is going to be green is going to be 3 out of 18. So then on the last branch, we've lost a blue one and a green one already. So the probability that the third one is red is going to be 10 out of 18. The probability that the third one is going to be blue is going to be 6 out of 18 because we've already lost the blue one. The probability that the last one is going to be green is going to be 2 out of 18 because we've already lost a green one. So now our tree diagram's complete, we can look down the branches that we need to work out the probability that all 3 discs are a different colour. So if we get a blue one to begin with, we could get a red one for the second one, and then we could get a green one for the third one. And then also, we could start with a blue one, get a green one for the second one, and get a red one for the third one. So it's this branch and this branch here that we're looking at. So we want the probability that the second one is red and the third one is green, so we need to times them together. So we're looking at 10 over 19 times 3 over 18, which is going to give us 30 over 342 on our calculators. So then we're looking at the probability that the second one is green and the third one is red. So that's going to give us 3 over 19 times 10 over 18, which gives us 30 over 342. So because these are the 2 options that can happen to give us the outcome of all 3 discs are a different colour, we can add them together. So we've got 30 out of 342 plus 30 out of 342 on our calculators gives us 10 over 57. So there's a 10 out of 57 chance that when Reggie takes out all 3 discs, they're going to be different colours. So our next question says, a coin is rolled into a grid of squares. It lands randomly on the grid. To win, the coin must land completely in one of the squares. Mira and John each roll the coin a number of times and record the results. Work out 2 different estimates for the probability of winning. So here we've got 2 players who've got very different experiences of playing this game. So the 2 different estimates are going to be with Mira's data and with John's data. So if we start by adding up the wins and losses of both of these players, then we know how many times they've played the game. So Mira's had 6 wins and 44 losses, so she's played the game 50 times. John's had 28 wins and 72 losses, so he's played the game 100 times. So using Mira's data, her estimate for the probability of winning is 6 out of 50 attempts. And using John's data, his estimate for the probability of winning is 28 wins out of 100 attempts. So part B says, which of your estimates is the better estimate for the probability of winning? Give a reason for your answer. Now this is one of these questions where the examiner's mark scheme will say, give a point for a good reason given. But with probability in general, the more attempts in a game or the more throws you've tried, the more accurate the probability will be. So the best answer that you can give here is 28 out of 100 is a better estimate because there've been more attempts at the game, so the probability will be more accurate than the other one. As long as you give a good reason for your answer, the examiner will give you a mark using their judgment. But generally, a bigger sample in probability is always more accurate, so I would always go down that route with these questions. So our answer is going to be 28 out of 100 because it's more accurate because there's been more attempts. So this next question is looking at the product rule we talked about in the key points video. It says for lunch, choose 1 starter and 1 main course. There are 4 starters and 10 main courses to choose from. 2 of the starters and 3 of the main courses are suitable for vegans. What percentage of the possible lunches have both courses suitable for vegans? So instead of writing out all of the possible outcomes that there could be, if there are 4 starters and there are 10 main courses, we can times them together to work out that there's 40 possible outcomes to this scenario. So for vegans, if there are 2 starters that are suitable and 3 main courses that are suitable, there must be 6 possible options where both courses will be suitable for vegans. So the probability of all of the possible lunches that have both courses suitable for vegans, there are 6 options for vegans, divided by the total number of possible outcomes, which is 40. So we can cancel that down to 3/20, which as a decimal is 0.15. So to write our answer as a percentage, we can times that by 100 to give us 15%. So our last question says, complete the Venn diagram. So we've got a circle for square numbers, a circle for even numbers, a bit that overlaps for when they're both square and even, and then a bit on the outside if they're not square and they're not even either. So number 1 we can put in the square bit. Number 2 is even. Number 3 is neither square nor even, so that can go outside. 4 is both square and even, so that goes in the overlap. 5 is neither. 6 is even. 7 is neither. 8 is even. 9 is square. 10 is even. 11 is neither. And 12 is even. So part B says one of the numbers is chosen at random. Write down the probability that this number is square and even. So because we want both square and even, we're looking at the overlap of the 2 circles. So we've got 1 option in there out of the 12 possible options, so the probability that the number is square and even is 1 out of 12. I really hope you found this video helpful. If you would like to have a little recap on the key points on this topic, click the link in the bio below. Don't forget to subscribe to GCSE Maths Help with the subscribe button below, or you can check out my Instagram page at GCSE Maths Help for more videos and tips. Thanks for watching!